Good day, everyone. Welcome back to our discussion on the topic application of integration. Today we'll be discussing volume of revolution. Now we've done looking for area under the curve, and to take that a bit further, we can also look for volume of rotation along either the x-axis or y-axis. If the area below the curve above is rotated, that is rotated 360 along the x-axis, then the volume of the solid is generated as shown will be found using the formula V is equals to the integral of pi y squared ds from B to A. Now note that we are integrating y squared with the s, so we have to look for a function in terms of s when actually solving for the volume. Also, about the y-axis or 360 or 4 right angle, then the volume of solid is generated is gotten by the formula the integral of pi s squared dy from B to A. Also note s squared and dy. That is, if we are rotating along the x-axis, the volume is the integral of pi y squared ds from B to A, and if we are integrating along the y-axis, the volume will be the integral of pi s squared dy from B to A. Now the solid figures generated by the two diagrams are called solid of revolution. Hence this subtopic is known as volume of revolution. We have a question from Ware 2000 that states that a bowl is designed by revolving completely the area enclosed by y equals to s squared minus 1, y equals to 0, and s greater or equal to 0 around the y-axis at y equals to 0 and y equals to 3. What is the volume of the bowl? And we are given the option. Now in our solution, since our rotation is around the y-axis, our volume will be given by V is equals to the integral of pi s squared dy from B to A. Now we are going to be making s the squared formula, so therefore y equals to s squared minus 1, simplifying will be y plus 1 is equals to s squared. That is, we are adding 1 to both sides. Now taking the square root of both sides, it becomes y plus 1 in bracket to the power of half, or the square root of y plus 1 is equals to s. Now substituting s in the formula, our volume will be equals to the integral of pi in bracket y plus 1 is the power of 1 over 2 dy from 3 and 0, and integrating it becomes pi in bracket y squared divided by 2 plus y from 3 and 0. At this point we are going to be substituting for the upper and lower limit, and when we substitute it will be equals to pi in bracket 3 squared divided by 2 plus 3 minus pi in bracket 0 squared divided by 2 minus 0, which will be equals to pi in bracket 9 divided by 2 plus 3, which will be equals to 15 divided by 2 pi cube units. We have another question that states that find the volume of revolution of the area bounded by the equation y is equals to 3 root s, the line s equals to 2 and s equals to 5 along the x-axis. Now since our revolution is along the x-axis, our volume of revolution will be equals to pi the integral of y squared ds from B to A, and we are giving y to be equals to 3 root s. So squaring both sides, y will be equals to 9s. That's 3 root s squared will be equals to 9s. So therefore, our volume will be equals to pi the integral of 9s ds from 5 to 2. Now we know that we are not going to be integrating the constant 9, so we can bring our constant over and we'll be left with 9 pi. So integrating s, it will be equals to 9 pi times s squared divided by 2 from 5 to 2, and substituting for our upper and lower limit, it will be equals to 9 pi times in bracket 5 squared divided by 2 in bracket minus 2 squared divided by 2. Now simplifying our powers, we'll be left with 9 pi times in bracket 25 divided by 2 minus 4 divided by 2. 25 divided by 2 minus 4 divided by 2 is 21 divided by 2. So it will be equals to 9 pi times 21 divided by 2, which is equals to 189 pi divided by 2 unit cube or cube units. We have another question that states that find the volume of revolution of the area shown below along the s-axis. And from the diagram, we can see our limit to be 4 and 2, and our equation is y is equals to s squared plus 1. Since we are revolving along the s-axis, our volume will be equals to pi the integral of y squared ds from b to a. Now writing down our equation y equals to s squared plus 1 and squaring both sides to get y squared will be equals to s to the power of 4 plus 2s squared plus 1. So therefore, substituting, our volume will be equals to pi the integral of s to the power of 4 plus 2s squared plus 1 ds from 4 to 2, and integrating, our volume will be equals to pi times in bracket s to the power of 5 divided by 5 plus 2s cubed divided by 3 plus s from 4 to 2. Now at this point, we are going to be substituting our upper limit and our lower limit, and when we substitute, it becomes volume is equals to pi in bracket 4 is the power of 5 divided by 5 plus 2 in bracket 4 is the power of 3 divided by 3 plus 4 minus in bracket 2 is the power of 5 divided by 5 plus 2 in bracket 2 is the power of 3 divided by 3 plus 2. And evaluating our powers, it becomes volume is equals to pi in bracket 1024 divided by 5 plus 128 divided by 3 plus 4 minus in bracket 32 divided by 5 plus 16 divided by 3 plus 2. Signifying both brackets by solving our fractions, we will be left with volume is equals to pi in bracket 3772 divided by 15 minus 206 divided by 15, and subtracting, we are left with 3566 pi divided by 15 cube units. Here are some exercises for you to try your hands on at home. The answers to these questions are found in our Hidden Fact Further Mathematics textbook. You can get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.